Today, this video will discuss the term 3 past year in 2020, question 17. A car with a headlamp separated by 1 meter emits yellow light of wavelength 570 nanometer approaches a man who is looking at the headlamps. The diameter of the pupils of the man's eye is 3 millimeter. Determine the resolving power of the man's eye. So this is the chapter of web optics where we learned about the diffraction and also the resolving power. So we have learned about the formula that the theta is the resolving power given as lambda over 8. And if the aperture, which is also the pupils in this case, is circular, we need also to include the constant of 1.22 into the formula. So the question is quite straightforward here. So what we need to do is just key in the value that the theta resolving power is equal to 1.22 multiplied by the wavelength 517 nanometer divided by the size of the slit or the aperture, which is 3 millimeter. So in the end, you should get the answer of 2.32 times 10 to the power of -4 radian. So second question is about the maximum distance between the man and the car when the yellow light can be resolved. So the formula here is actually provided by the Rayleigh criterion that we need the minimum of 2.32 times 10 to the -4 radian so that the light can be resolved. So if the value of the angle here is minimum, so from the formula that we also mentioned in the video already, that the D here would be the maximum value. So what you need to do here is also use the formula again. So the maximum distance will be equal to X, which is the 1 meter, okay, the distance between two headlamps, divided by the minimum angle value, okay, 2.32 times 10 to the power of -4. So that will be 1 divided by that. Okay, so what you get is that the maximum distance is about 4,300. Okay, so meter. So that will be the maximum distance between the man and the car for the light to be resolved. So what do you mean by the word maximum distance is that when the man stands at a distance further than this, his eyes couldn't resolve the light clearly, and it seems like he could only see one length from the car at a very far distance away. So the last question is about the effect of the maximum distance when the yellow light is replaced by the blue light. So first of all, blue light has a shorter wavelength than yellow light. So from the formula that we have, the theta is proportional to the wavelength. So with shorter wavelength, we have a smaller value of the minimum angle required, and this gives us a higher resolving power. With the higher resolving power, this causes the maximum distance increases for the light to be resolved. So that's all for this question, and thank you for watching.